Not long ago, the biggest technology companies in the world reached the same conclusion. Relying on NVIDIA had become dangerous. Google built its own AI chips. Amazon introduced Trainium. Microsoft unveiled Maya. Meta began designing custom silicon. Even OpenAI started looking beyond NVIDIA. At first glance, it seemed obvious. If everyone could build their own chips, NVIDIA's dominance would eventually disappear. Instead, the opposite happened. The more companies tried to reduce their dependence on NVIDIA, the stronger NVIDIA became. Its market value climbed past $1 trillion. Then 2. Then 3. Which raises a fascinating question. How can one company remain so far ahead when some of the richest businesses on Earth are spending billions trying to catch it? The answer isn't faster hardware. It isn't better marketing. And surprisingly, it isn't artificial intelligence either. NVIDIA's greatest advantage is something most people have never heard of. A software platform called CUDA. It isn't sold in flashy advertisements. Consumers rarely talk about it. Yet it may be the single most valuable piece of software ever created for modern computing. Because while competitors spent years trying to build better chips, NVIDIA spent decades making sure developers never wanted to leave. That decision transformed a gaming company into the backbone of the AI revolution. Everyone thought NVIDIA was in the gaming business. When people think about NVIDIA today, they picture AI. But that's not how the company became successful. For years, NVIDIA was known for one thing: gaming graphics cards. Every new generation promised better visuals, higher frame rates, more realistic lighting. It was a successful business. But it wasn't unique. AMD was competing aggressively. Intel had enormous resources. The graphics market moved fast. Winning one year didn't guarantee winning the next. Jensen Huang understood something many people overlooked. The real value of a graphics processor wasn't graphics. A GPU could perform thousands of small calculations simultaneously, far more than a traditional CPU. For video games, that meant realistic graphics. But Jensen saw another possibility. What if those same processors could solve scientific equations, analyze medical research, simulate weather systems, train artificial intelligence? The hardware was already capable. The problem was, almost nobody knew how to use it. Researchers who wanted GPU performance had to write incredibly complex code. Every manufacturer handled things differently. Development was slow. Debugging was frustrating. Even brilliant engineers often chose CPUs because they were easier to program. The technology existed. The ecosystem didn't. Most companies responded by building faster hardware. NVIDIA decided to solve an entirely different problem. The billion-dollar bet nobody wanted. In 2006, NVIDIA introduced CUDA. At first glance, it didn't seem revolutionary. It wasn't a new graphics card. It wasn't a faster processor. Most consumers never even heard its name. CUDA was something much less exciting. A software platform. It gave developers a standardized way to program NVIDIA GPUs for far more than gaming. Today that sounds obvious. Back then, it looked like a distraction. Investors wanted better gaming products. Customers wanted higher frame rates. Nobody was asking NVIDIA to become a software company. Building CUDA wasn't cheap. It required compilers, programming libraries, developer documentation, training materials, engineering teams, customer support, years of investment before meaningful returns. There was no guarantee developers would adopt it. Many businesses would have abandoned the idea. NVIDIA doubled down because Jensen Huang wasn't trying to win the next product cycle. He was trying to build an ecosystem competitors couldn't easily copy. That distinction changed everything. A faster graphics card can be reverse engineered. Software ecosystems cannot. Why developers stayed? Technology companies often believe customers create moats. In reality, developers do. Once programmers invest years learning a platform, they rarely switch unless the alternative is dramatically better. CUDA gradually became more than software. It became a language. Universities began teaching it. Researchers published CUDA-based papers. Scientists optimized simulations around it. AI startups built products with it. Every new project made the platform more valuable. Every new developer strengthened the ecosystem. This created one of the most powerful business advantages imaginable: a network effect. Not the kind created by social media, the kind created by knowledge. Imagine spending years building software around CUDA, training your engineers, optimizing your infrastructure, publishing research, creating internal tools. Now imagine someone offers you another chip that's slightly faster. Would you rewrite everything? Retrain your entire engineering team? Replace years of software optimization? Probably not. The cost isn't buying new hardware. The cost is rebuilding everything surrounding it. That's exactly what NVIDIA understood nearly 2 decades before the AI boom. While competitors focused on making better chips, NVIDIA focused on making switching feel impossible. And by the time the rest of the industry recognized what CUDA had become, the foundation had already been built. The AI revolution didn't create NVIDIA's advantage. It simply revealed it. The AI revolution arrived 20 years late. For years, CUDA looked like an interesting piece of engineering. Nothing more. It helped researchers, scientists, universities, a handful of specialized industries. But Wall Street barely paid attention, because there wasn't a business worth trillions of dollars built on artificial intelligence. Not yet. Then everything changed. Not because NVIDIA released a revolutionary new chip, but because the world suddenly needed exactly what NVIDIA had been preparing for since 2006. Large language models, generative AI, machine learning. Training these systems required enormous amounts of parallel computing power. GPUs were perfect, but having powerful hardware wasn't enough. Researchers also needed software that could efficiently manage thousands of GPUs, optimize workloads, and integrate with the AI frameworks they already used. CUDA had spent nearly 2 decades solving those problems. By the time ChatGPT introduced generative AI to the public, millions of developers already knew CUDA. Universities had already trained students on it. Companies had already built their infrastructure around it. The tools already existed. The documentation already existed. The community already existed. The AI boom didn't create CUDA. It simply made the entire world realize how valuable it had become. Suddenly, every company wanted NVIDIA GPUs, not just because they were powerful, because they fit into an ecosystem that was already working. Why competitors still struggle? At first glance, it doesn't make sense. AMD builds excellent GPUs. Google has its own tensor processing units. Amazon created Trainium. Microsoft introduced Maya. Even Meta has invested heavily in custom AI hardware. So why hasn't anyone replaced NVIDIA? Because they're solving only half the problem. Building a competitive chip is incredibly difficult. Replacing an entire software ecosystem is even harder. Imagine telling a company that has spent years training hundreds of engineers on CUDA to start over, rewrite their software, replace their optimized libraries, retest every AI model, retrain every developer, update every workflow. Even if another processor is slightly cheaper or slightly faster, the switching cost becomes enormous. This is why businesses often stay with platforms they already understand. Not because alternatives are bad, because changing everything around them is expensive. The same principle explains why companies continue using Microsoft Office, Salesforce, or Adobe despite new competitors appearing every year. Software ecosystems create habits. Habits become standards. Standards become dominance. CUDA became the standard for AI development long before AI became mainstream. That gave NVIDIA something competitors couldn't simply manufacture. Jensen Huang didn't build a chip company. Most CEOs think in product cycles. Release a better product. Increase sales. Repeat. Jensen Huang played a different game. He invested in something that wouldn't generate immediate profits. Developer relationships. Educational programs. Software libraries. Research partnerships. Long before artificial intelligence became the biggest technology trend in the world, NVIDIA was already teaching researchers how to build with its platform. That patience looked expensive at the time. Today, it looks visionary, because every AI breakthrough strengthened NVIDIA's position. Every new startup trained on CUDA. Every university course expanded the talent pool. Every company hiring AI engineers found people who already understood NVIDIA's ecosystem. The company wasn't simply selling hardware anymore. It had become the default operating environment for modern AI development. And defaults are incredibly difficult to replace. The real lesson behind NVIDIA's success. People often describe NVIDIA as the biggest winner of the AI revolution. That's only part of the story. The company didn't suddenly become successful because artificial intelligence exploded. It spent decades preparing for a future that most people couldn't yet see. While everyone else competed over specifications, clock speeds, and benchmark scores, NVIDIA invested in the people who would eventually decide which hardware the world used. Developers, researchers, engineers. Once they chose CUDA, the hardware choice often followed naturally. That's one of the most powerful business strategies ever executed. Instead of building a better product, build a better ecosystem. Because products can be copied, prices can be undercut, performance advantages eventually disappear. But an ecosystem, one supported by millions of developers, thousands of software libraries, decades of research, and countless businesses, becomes incredibly difficult to replace. Today, NVIDIA's market value measures in trillions of dollars. People often assume those trillions were created by AI. In reality, the foundation was laid nearly 20 years earlier, inside a software platform that almost nobody talked about. The biggest bet in NVIDIA's history wasn't on artificial intelligence. It was on developers. And that may be the smartest business decision Silicon Valley has ever seen. If you found this helpful, don't forget to like, comment, and subscribe for more.